Hey everyone, and welcome to The Explainer. So today we're diving into a piece of tech that's kind of working behind the scenes, but it's huge. It's called Microsoft's Semantic Kernel, and it's basically what's turning our simple chatbots into something, well, something much, much smarter. We're going to look at how it helps an AI go from just talking to actually doing things.
Okay, let's just jump right in, because this all starts with a question that I bet you've probably asked yourself at some point.
I mean, we've all seen these large language models, LLMs, do some pretty mind-blowing stuff, right? They can whip up a poem, spot a bug in your code, even explain quantum physics. But then you ask it to do something that seems simple, like, hey, book me a flight, and it just can't. What's up with that?
Well, the problem is perfectly captured by this idea of a brain in a vat. Think about it. An LLM is this incredibly powerful brain, just floating there, completely disconnected from everything. It can think about booking you a flight, sure. It knows what the steps are, but it has no hands to type, no eyes to see a website, and no way to actually connect to the airline system. It can't do anything.
And this really gets to the heart of the difference. A simple chat interaction, that's what we call stateless. You ask a question, you get an answer, the conversation is immediately forgotten. But booking a flight? That's a whole different ballgame. You need something stateful. It needs to remember who you are, where you want to go, use actual tools to check prices, and string together a whole bunch of steps to get the job done.
So, how do we solve this? How do we give that brain in a vat a body to interact with the world? Well, that's where this idea of an AI orchestrator comes into play.
And that orchestrator is Semantic Kernel. It's an open-source SDK from Microsoft, and you can think of it as the nervous system connecting that AI brain to the outside world. It's really more than just a piece of code. It's like an operating system for AI. It's the thing that manages the communication between the AI's ability to think and all the real-world tools it needs to actually do.
And you should know, this isn't just some side project. Semantic Kernel is the real deal. It's the engine that actually powers Microsoft's own Copilot experiences. It's built to be super robust for big enterprise applications. And what's really cool is that it's model agnostic. That just means you're not locked into one AI model. You can plug in models from OpenAI, from Azure, Hugging Face, you name it. It provides this solid foundation for building these really smart, reliable AI agents.
Okay, so how does this whole thing actually work? Let's look under the hood. It really all comes down to three core ideas, or pillars, that make it all happen. Pillar number one is plugins, and this is easy. If the LLM is the brain, plugins are the hands and feet. They're the tools that let the AI take action in the real world, things like calling an API to get the weather, running a calculation, or, sending an email. It's just a piece of code that does something. Second, we have memory. This is absolutely crucial. This is how we give the AI a long-term memory, and, maybe more importantly, how we stop it from just making stuff up, when it hallucinates. The memory component connects the AI to your actual data, your files, your company's knowledge base, so its answers are based on facts, not fiction.
And the third pillar, this is really the magic ingredient, planning. The planner is the part that does the thinking. It looks at what you want to do, your goal, and then it looks at all the tools it has, the plugins, and all the information it knows, the memory, and it figures out a step-by-step plan to make it happen. It's the strategist.
Now, let's just double-click on that memory pillar for a second, because there's one specific technique here that is a total game changer for making AI useful and trustworthy. It's called Retrieval Augmented Generation, or RAG for short.
So here's the RAG pipeline in a nutshell. First, you take all your trusted documents, think company wikis, PDFs, whatever, and you feed them into the system. It chops them up into little, digestible chunks. Okay, so now step two. You ask a question. The system then instantly searches through all those chunks to find the ones that are most relevant to your question. And here's the key part. It takes those factual chunks and stuffs them right into the prompt it sends to the AI, along with your original question. It basically tells the LLM, hey, answer this question, but you are only allowed to use the facts I'm giving you right now. It completely grounds the AI in your reality. All right, so we've given the AI tools to act, and we've given it facts so it's not making things up. Now let's get back to that reasoning engine, the planner, because this is where the real intelligence happens. It's actually pretty wild to see how this has evolved. In the old days, like a year or two ago, A developer had to sit there and manually code every single step. First do this, then do that. Super rigid. But now, we have something called function calling, and it's a huge shift. We basically just give the AI a toolbox and a high-level goal, and it figures out the sequence of steps all by itself. And that right there is a fundamental change in how we build software. The developer's job isn't about writing all the fiddly step-by-step logic anymore. It's about creating a really good set of tools with really clear descriptions of what they do. The AI becomes the one that calls the shots, picking the right tool for the right job at the right time.
Now, this automatic function calling is pretty much the go-to method now because it's fast and flexible. But Semantic Kernel is cool because it gives you options. There's another one called the Handlebars Planner. Instead of just doing the task, it first creates a reusable template of the plan. And why is that useful? Well, it's great for really complex jobs where you might want to check the AI's work, maybe tweak the plan a bit, or even save that plan to use it again and again without having to ask the AI to think it all through every single time. It can save a lot of time and money.
Okay, so let's put it all together. We have plugins, which are the hands. We have memory, which provides the facts. And we have the planner, which is the brain. So, what happens when all of these things work in harmony?
What you get is something way, way beyond a simple chatbot. You get a true AI agent, an autonomous system that can understand and achieve really complex goals all on its own.
And this is the whole point, right? This is the big payoff. An agent that's built on a framework like Semantic Kernel can do 4 key things. It can reason about what you actually want. It can remember past conversations and important data. It can act by using its tools to interact with the world. And because of all that, it can solve your problem from beginning to end without you holding its hand.
Look, this is so much more than just a minor update. It's a completely different way of building software. We're moving from a world where we write code that follows a strict set of instructions to a world where we build systems that can actually reason, make plans, and adapt to new situations on the fly.
And that's the really big idea I want to leave you with. Just think about it for a second. What if every single app on your phone or your computer didn't just wait for you to click a button, but had its own reasoning engine inside? An engine that could understand your ultimate goal and then figure out the best way to get you there. That's the future we're talking about, and it's what tools like Semantic Kernel are making possible right now. Thanks for joining me.